Great. Okay, so I'm Vivian Loftness, a professor in architecture. I'm going to do a bookend with Erica Cochran. And actually, I see that a number of our students and graduates are here, so I'm sort of thrilled to have a good representation from the building sector. I had the privilege of serving along with Chris Hendrickson from the School of Civil and Environmental Engineering on 2 different National Academy reports that are focused on decarbonizing the United States. The first report was what we had to do immediately to achieve a critical level of decarbonization by 2030. And the second report was what are we going to have to do beyond that to actually get carbon neutrality by 2050. We did not set a new goal, but we did put down a carbon price on the table for the public policy decision makers. These reports basically conclude a number of things. One is we have to electrify everything. We're going to have to get off of all the fossil fuels that Nick had just talked about. We have to improve energy efficiency and productivity of every unit of electricity that's being used. I'll come back to that. We need to produce carbon-free electricity, so we're going to have to find alternative renewable sources, and maybe hydrogen is a key part of that. I'll be interesting to further that conversation. We need an innovation toolkit, and we need to plan and permit and build critical infrastructures. We're doing this because it will strengthen the economy, it will promote equity and inclusion, it will support communities and businesses and workers, and it will actually maximize cost effectiveness. So these are the goals of the reports. They're both downloadable directly from the website. I have a particular message to this audience and the online audience that may be here or in the future. These charts, this is a New York Times article just recently, are totally wrong. They're throwing a source in with an end use and giving you the impression that buildings don't matter. And the reality is, as Erica mentioned, is that 70% of that electricity use is in buildings. 70% of the yellow line belongs in the purple line. And then all of a sudden you say, whoa, we got to get our buildings right, and the activities and equipment in our buildings. And I want to talk about that. These pie diagrams that show up, thousands of these pie diagrams show up every time you look at what is the greenhouse gas, what is the CO2, what is the energy story, will always put electricity as if it is an end use. And this has to do with scope 1, 2, and 3 divisions, which are relatively artificial. The real question is, where is the energy being used? That's what an end use is. And when you start to look at that, you realize that if you take 70% of the electricity and put it into buildings, and you take 20% or 25% and put it into industry, and the last little sliver shows up in transportation, which is not yet very electric, and agriculture, then you have a picture of what we have to do. And when you look at embodied energy, which the very first talk talked about, the answer becomes even more significant because the building sector constantly specifies materials. And they specify very energy-intensive materials. So there is a lot of things we can do, and we can do these very cost-effectively. The actual carbon costs for per unit of carbon are really, really effective, way more than carbon capture and storage, which is at the other end of the scale. Number one, we are so sloppy in our buildings. We use energy as if there is no tomorrow. And if you look at this New York City benchmarking and disclosure data set, you can start to see that the best hotels will consume, let's see, in a hotel, 320%, or the worst hotels will consume 320% of what the best hotels are consuming. And if you start to look at what we're doing, you realize that there's a big differential in the quality of the buildings. ACEEE has tried to look at where is the most carbon savings to be had, and then trying to begin to figure out what it's costing. And everything at the top of this chart is in the building sector. I want to talk about a few of those. Appliance and equipment efficiency is huge. Oh, this just as a key point. We need to save at least 50 quads per year by 2050 to be carbon neutral. We'll meet the rest with renewables, but we've got to get 50 quads out of our system. 5.6 of those quads, 10% of those quads, is in appliance and equipment efficiency. And if you look at what Lawrence Berkeley National Labs and other labs have done, if they've taken the refrigerator, and this is exactly what Nick's chart was a lot about, we've actually improved the amount of efficiency and functionality in our refrigerators while we have driven down the amount of energy that's needed. The same is true with lighting and other things where the federal sector has made a commitment to dramatically reducing. We have to turn these into future mandates for equipment sales and purchases. Just to give you a sense of what the research at Carnegie Mellon School of Architecture and the Center for Building Performance and Diagnostics, we are actually trying to mine the data to find out what investments really do save energy. And this is Yuji Tsu's PhD thesis. She's now at Lawrence Berkeley National Labs. And she was able to find that if you really want to dramatically reduce energy, buy new cooling towers, buy new air handlers, get them very deeply efficient, and repair control systems. Those will get your best energy savings based on a large database that General Service Administration has privileged us to analyze, and we continue to work on with GSA. Another PhD thesis from Ray Yun, who's now teaching at Hongik University, was focused on engaging the occupant in energy savings. And there's a lot of pushback. I mean, a lot of control systems are disappearing. You can hardly find a thermostat, or in some cases even a light switch. We've basically told the world that the occupant just mucks it up. Not true. The occupant makes it better. As Erica was saying, it's all about the people. And Ray created a dashboard for PNC Bank. We did a joint research project with PNC and gave them 3 functionalities. One is just, here's information, no controls. One is information with controls. One is information and controls and feedback about what would make the biggest difference. And the savings were between 3 and 5% of an already very efficient building, because PNC had already removed super energy intensive water coolers and copiers, and they had gone to laptops from desktops, huge investments that they made to drive their 200 watt hours per hour of occupancy down to 100 watt hours. That's just by selection, which, by the way, architects and facility leaders do all the time. They select equipment. We were able to get it down to 50 watt hours per hour of occupancy. So you can really show the power of the occupant to be part of the answer. We do need to change codes and standards, and we've got 2 of our grads who work for the city of Pittsburgh who are trying to be active proponents. I can see them here in the room. We need to look at innovation, so smart homes and smart commercial buildings. I've got another 2 grads in the room who've been doing a huge amount of machine learning and data analytics, where we actually look at fault detection. So in this room, all the air conditioning, the building automation system is tracking how much energy is being used, it's tracking the temperature, but it's also tracking when there's a weakness in the system, where the temperature is not being met, or where it's being overcooled, or it's overheated. And when those faults show up, we can actually analyze how much energy it's costing and put a price tag, which we've done with GSA on something they call the total cost of energy, or TECI labeling for their buildings, for every fault that their building is reading. Then there are urban issues that our School of Architecture is also aggressively working on, and urban databases that we're trying to mine, both because of the energy impacts, but also because of the equity and the resiliency impacts. And so this PhD thesis by Susie Lee is focused on smart surfaces, and to what extent does it matter how much pavement we have? Over 60% of cities, somewhere between 60 to 80%, are hard surfaced. Dark hard surfaces, the roofs, the streets, the sidewalks, the parking lots. We hardly have any green left. And of course, it's contributing to heat island, it's contributing to flooding. It's a huge amount of embodied carbon, because concrete is filled with carbon-intensive processes and materials. And she's able to show what happens when we reverse that design process. And finally, we really want to get at retrofits, because we can't build everything new with innovative everything. And we are going to want to look at ways to electrify in a smart way. And for that, I want to close with a key area of research that is just emerging in the building sector, called grid energy efficient building, or GEB systems, right? So they're looking at solutions where buildings play a critical role in generating electricity, in managing peak loads, and in storing the energy. The New Buildings Institute basically says we've got to get efficiency first. Don't do anything else first. Don't electrify before you make it efficient. Then find a renewable source. Don't electrify until you've got a renewable source. Then we can start to electrify, but please manage it on site and store it wherever possible. And they look at what you can achieve if you start to design that way. If we electrify everything tomorrow, we will have peak load demands in January that will bust the grid. Absolutely bust the grid. July right now is the grid busting moment. It is going to be overwhelmed by replacing heat with electric heat sources, even with 300% efficient heat pumps. So we really have to be prepared for efficiency before we electrify everything. And then we need to store. We need to find a way to store, because it's all thermal. It's low temperature energy. It's not what the industry needs in terms of process heat. It's really low temperature stuff, which geothermal can meet with very modest heat pumps. And we've had a wonderful master's thesis project. And by the way, all of this work, I've been working with master's thesis with the National Academy to try to really flood this with content so that we've written guidelines that are meaningful. This master's thesis by Ciali, who's now at the New Buildings Institute, looked at how buildings can become thermal energy storage machines. But you really have to invest in the buildings. When you do that, you get to net zero. This is a net zero campus building at Georgia Tech. I hope Carnegie Mellon will build a building that is net zero in the next 5 to 10 years maximum. I mean, the longer we wait, the further we fall behind. This is the McKinsey carbon calculator. There's a lot of debate about whether this is completely accurate, but the reality is buildings are your cheapest carbon savings, putting better systems in buildings, and all this is written up in these 2 reports. And hopefully I did a good job on my 10 minutes because I know I had too much content. But.
All right, I think we have time for one very quick question if anyone has one.
Thank you for the lovely talk, Professor Vivian. I just wanted to talk about one thing that I think you must be also highlighting it further, that most of the buildings, like commercial buildings, are now underutilized and we are not using it as much we used to. And maybe this can also impact the carbon neutrality 2050 goal because we are not really using it the way we were using it. So what are your thoughts on that thing?
Yeah, I mean, this is a huge challenge right now for the building industry altogether. The buildings are highly underutilized. Surprisingly, the energy loads have not gone down as much as they should. For buildings that are 20% occupied, they still have about 80% of the energy demands, right? So we've got a management issue that we've got to find, number one. But number two, we're going to have an adaptive reuse issue. We're going to see a lot less new construction and a lot more adaptive reuse. So we're going to turn office buildings into housing. We're going to be looking at mixed use. I mean, there's going to be a shift in the way in which there's no question that working from home, we've all realized that there's a lot of reasons for working from home has made for better solutions, but it displaces the energy demands, and in some cases it makes them redundant. We have 2 energy systems operating at the same time. So more controls, more smart controls, and user engagement, right?